Hello and welcome to this edition of Ampit Software's Introduction to Forensic Multimedia Analysis. In this module, we'll talk about video content triage. I'm your host today. I'm Jim Horrocks, Director of Customer Support and Training for Ampit Software. Prior to this posting, I was the Senior Forensic Multimedia Analyst for the Los Angeles Police Department, and I've been seen on the History Channel and National Geographic doing this very thing. Some of the things that we're going to talk about today in our agenda is the camera fit for the purpose of answering the questions for which we've been asked to answer? And along those lines, we'll find out what questions can be answered with video evidence, along with the most common question: can you zoom in on that? And can you fix that? So let's get started by talking first about the workflow, right? Peer-reviewed, published workflow. This is the workflow that we teach at Ampit Software in our training programs. It's an expanded workflow that deals all the way with simple can you clarify, can you enhance, all the way down to photogrammetry, content analysis, and comparative analysis. And it starts with a case. Right, you've been given a case, whether you're a private laboratory, whether you're in police service, government service. Right, you have to assemble all of the evidence, and you have to assemble the questions that need to be answered with that evidence. Questions like, what is the license plate? How tall is that subject? And so on. Then you move on to file triage. You've received these files. Can you view them? Right? Are they proprietary? Do they require a codec or a player? For those proprietary file types, we want to create a proxy file. Right? We can do that in Ampit 5, or we can do that in DVR-Conv, our standalone conversion tool. But once you have that proprietary file type, or if you have files that don't require any kind of conversion into a proxy, we'll bring those into Ampit 5. And we'll ask the question that we're going to talk about today in this module. Can I answer the questions with this file? Do I have enough data in order to effectively and reliably and valid and repeatable, can I answer the question with this file? Right, and we start the workflow with restoration, optical problems, mathematical problems. Right, we address focus, we address optical things like blur and stabilization. And then we move into the clarification, what I like to call make pretty things. We deal with light and color, edges, noise removal. All right, we want to handle all these things first before we start doing content analysis, the actual, what is this kind of questions, because we want to know if it's an object or an artifact, right? A noise, some kind of compression thing, right? Interpolation is next on our workflow. It's just a fancy word that means resize or rotate. Right? And after we've done that, we might need a touch of sharpening. And now our files are ready for analysis. Photogrammetry, right? Measurements, content analysis. What is this thing that I'm seeing? Or comparative analysis. Is this thing that I'm seeing in the video the similar or the same as or the thing that I have in property, like t-shirts and cars and whatnot? You can also do some redaction when requested. And then when you're finished with all that, are you putting it out to print? Are you putting it out to digital media? Are you uploading your results to your DEMS? All right, that is the workflow for video and images. When it comes to those three of the four domains of analysis: photogrammetry, content analysis, and comparative analysis. For authenticity questions, we have a separate workflow for authentication and a separate tool, Ampit Authenticate. But first, let's talk about the cameras, right? We hope that the CCTV installation is purpose-built, that every camera has been deployed to address a specific purpose, right? That there's a purpose statement along with the security plan. The camera that is watching the entry to the business is designed to get identification quality footage. The camera that's mounted on the fourth story overlooking the parking lot at the big box store is designed to monitor the parking lot, right? And so the camera's purpose should be defined, and more often than not, it's not. But hopefully that there is some discussion around why the camera was there, right? So consider a use of force captured by a body camera, right? Consider the use of force paradigm. What are the things that happened at 30 feet? What are the things that happened at 20 feet? And can I answer those questions with the footage that I have? Right, we're going to be doing the same thing with CCTV footage. Right, in order to know what the purpose is, right, I have to know what this system was designed to do. Right? As a former test and validate engineer, I know that I can't quantify things like transparency or complaint reduction or protection or security. These are these are qualitative statements. These are not things that I can assign a number to, right? A lot of people install CCTV in their homes, for example, because they want security, but they don't necessarily know all of the design parameters for putting cameras out to get license plates, to get faces, and those types of things that help investigators answer questions with the footage that they record. All right, so what's the question? A whole bunch of us sat down uh, last year, and we came up with the 35 top questions that investigators are asking about video. Right? Can I zoom in on the license plate? Is the person in the video the person that we're looking for? Can you tell me if it's been altered? Can you tell me about the make and model and year of the vehicle? Do you know how old the person is? Do you know how far apart these two things are? Can you redact, and so on? So we came up with this list. But the questions are kind of divided into simple things, right? Simple things should be fast and easy. Conversion of format. I just need to see this file, right? Can you give me something that I can play on my desktop computer? Right, moving in level of complexity, the qualitative requests, improving quality, things that we typically consider enhancements, seeing in the dark, turning on the lights, fixing color, those types of things, qualitative requests. And then on the complexity level further down are quantitative requests. These are requests that yield a value or a number. How tall is that person? How far away is that thing? How many of them are there? Is this thing that we see, this shirt that we see in the footage, what we have in the property room? Is this car that we see in the footage a 1994 Mercury Grand Marquis, for example? Or is it an original? Right? Or has it been duplicated? Has it been altered in some way? These are quantitative requests. But the most common question that analysts get from investigators is, can you zoom in on that? So I want to talk a little bit about zoom and what that means. We're going to start with this old exercise of mine. Right? Here we have a view of a parking lot down at Los Angeles' harbor where they unload rental cars for delivery to rental car facilities. So we went out and we did a test. And the question is here, as you can see the red arrow pointing to the rear of a vehicle, can I zoom in on that license plate, right? Or what I jokingly say, which of those 5 pixels would you like to see better? Well, let's take a look at this, right? What is the purpose of each camera view? Now, the Home Office in the UK has done a great job over the years in documenting and standardizing and writing about CCTV. Right, they've got 4 basic categories of views: the detect or monitor view, the observe or the recognize or the identify. And the percentage that you see on the screen here, that is the percentage of the screen that the thing that you're interested in will occupy. So if I'm interested in identifying something, then 100% of that view should be dedicated to identification. Right? Otherwise, 50% gives you recognition. It's not something that I can prove, but if you know the person in the footage, you might be able to say, yeah, that's the person that I know, right? So wherever you're deploying cameras, each one should have one of these 4 purposes, right? The camera that's overlooking the entirety of the parking lot at the big box store is a monitoring camera, a detect camera, right, as an example. And so those types of cameras, the monitoring and detecting, they're there for traffic flow. They're there for the movement of people. When I don't need to know individualization of things, just flow of things, right? The observational view gives me the presence of people, right, without needing to see their face. That's good for counting heads. How many people do I have in the queue at the grocery store? And so I can call 3 as a crowd and get more staff. Recognizing is a slightly tighter view, right? Somebody that I know, somebody that you'd be able to look and say, oh yeah, that's him. That's the person that I know. Identification is the highest level of quality, right? And it's something that I can take to court and prove beyond a shadow of a doubt that the person has been identified, whether that's a manual process, some analyst is making that comparative analysis for you, or you're planning on feeding it through some license plate recognition or facial recognition system, right? That the amount of quality, the amount of pixels on target there is very important. Right, so here we have, for our demonstration, an Avigilon system 16 megapixel camera. And in this Avigilon system is end-to-end vigilance, end-to-end digital. It's their entire system end to end. Right, so we can see the entire parking lot, and if you look up in the top left corner, you can see the skyline of the city of Los Angeles. Right, you can see a whole lot with this monitoring view. And we want to zoom in, right? We want to see the gentleman that's exiting the car. And so as we zoom in, we limit the field of view. Right? We're no longer able to see the skyline. We're no longer able to see the entirety of the parking lot. And now we can observe the presence of people moving around. Right? We can see and observe directions of travel and so on. But we want identification. So we're going to zoom in even farther into a recognition view. Now, if you knew this person, you might be able to say, hey, yeah, that's so-and-so, right? Or that's so-and-so's car. You're not going to have enough pixels on target usually to run facial recognition or to run license plate recognition, but somebody who knows this person or knows this car might be able to say, oh yeah, that's Joey's Pontiac, right? I recognize him. Then we zoom in even tighter, and we get to enough pixels on target to be able to run identification quality comparisons or machine reading exercises. Right? In this case, I've actually blurred the face and redacted the license plate because you could literally run that through and get a hit, and we wouldn't want that. Right, now we're going to compare that 16 megapixel image to a traditional 4SIF CCTV monitoring image that's been zoomed in, that same exercise that we've done. And which would you rather have? Right, in one hand, on the right, you can see somebody that is absolutely human, and you can see a car that you would have a very easy chance of doing at least a class level identification, right? A Pontiac Grand Prix, etc. Not necessarily an individual without the license plate, but you'd be able to tell what kind of car it is. And then on the left, you have the 4SIF CCTV image, where it's just blobs of stuff, right? Not very helpful for investigators. And the reason for this is that the Avigilon system, that 16 megapixel, right? You have 16 million pixels. The 4SIF image has less than 500,000 images. Pixels. So the difference is a 97% reduction in the amount of data, the amount of available pixels on target. Plus you have an aggressive compression that a lot of CCTV manufacturers use to save space on hard drives. That compression is just another way of saying throwing stuff away, right? And you can see the results for themselves. Now, this isn't an Avigilon marketing campaign. I'm happy for their help in creating this exercise, but I did want to show the difference between a well thought out installation for passive surveillance when you're going after the fact to try to get documentary evidence, and something that was just installed based on a budget, a 4SIF image. And so from a triage standpoint, do I have enough pixels on target to answer the question? There's two schools of thought on this, and I'm going to show you here in this slide what those in the United Kingdom are doing. This is from the Home Office again, and the Home Office documentation, they recommend a percentage of the screen approach. So for example, if I wanted to identify somebody and all I had was a SIF image, like 240 320 by 240, right, I would need 139% of the available pixels. In other words, it's red or orange there because it's not going to happen. I don't have that much data. So identification quality stuff on anything less than 640 by 480 is simply not possible, right? That's what this chart is telling us. It's really hard to do quick. It's really hard to do fast to use this methodology. And so I like what Axis Technologies are doing in terms of, instead of a percentage, I want to use pixels on target, right? Pixel density. And what this chart is telling me is that in challenging conditions, high compression at night with motion, with problems, I need 80 rows of pixels across a face or across a license plate to be able to stand a chance in making an identification. Right? In very good conditions, when the camera is close to the object, when there's not that much compression, when it's daytime and so on, I can get by with 40 rows of pixels. Right? For detection, just to recognize that somebody is human, for example, I can get by with much less. But I want license plates, I want faces, and to get there, depending on the distance to target and compression, somewhere between 40 and 80 is the minimum amount of pixels on target that I would need to answer those questions. So within AMPID 5, we have the selector tool, right? It's in the tools panel. It works like a square, and it's very easy to use. I just click and hold and draw a box around the target, right? So here it's telling me that I have 15 rows of pixels in that very generously drawn box around the front area where the license plate would be in this car. And I ask, the question as the analyst to the investigator, how many characters are in the license plate for this state? And the answer is 6. And then for each character, the alphanumeric, there is some space around each character to space them out, and then there's the border. So you take that amount and you divide it by the available pixels, 15, and that you come up with about 2 pixels per character, right? Absolutely mathematically not possible to develop a 2 or a 3 or a Y in that little amount of space, right? It's simply not possible. And we can look at some other instances of this, right? We have 22 pixels wide. We have a license plate with 7 characters, a center medallion. We have the white space around it, right? The math just does not add up. But with the selector tool, we can easily triage things, right? Same thing here. How many pixels on target, right? Do I even stand a chance, right, with 20 pixels of width? I have 34 and I'm starting to see outlines of things, right? And a lot of people are tempted to say, I can just about get it. Well, just about and identification don't mix, right? You're getting close, but you're not quite there. We need a few more pixels on target. And unfortunately, you can't get that after the fact. But triage is that step that says, do I spend a lot more time on this? Or is there no chance of getting an answer? And thus, I don't want to waste time. Right here again, 6 characters, white space. I'm getting close, but no cigar. Right. So we look at things that can we fix, right? What are the things that we can fix in AMPID 5 with our tools, right? So our triage, we want to identify what's wrong with it, right? What's wrong with this picture? Having the workflow helps, right? Identifying what the problem is and then correctly applying one of our over 120 different tools and filters to solve the problem, right? So we have a highly compressed image. We can restore that using our deblocking tool. And we might not be able to get all of the characters, but having 3 or 4 of the characters plus a model and a color will help in a database search. Right, sometimes it's too dark, so we can equalize the histogram, bring that stuff out of shadow, bring that stuff out of darkness, and bring it into the light. Right, sometimes there are blurs. Right, we can do motion blur, which is a straight line blur. We can do optical blur, which is kind of a bubble blur. Essentially, we give it glasses. And sometimes motion is not in a straight line, and so we have a non-linear deblur as well. But these are all dealing with point spread function problems. A point that has spread into a line because of the motion of the object or the camera, or both in the case of like handheld mobile devices. Right, sometimes you got a bunch of nighttime noise, right? So we can do frame averaging. Again, we're doing all of this in one tool, AMPID 5. Right? We're not sending you out to a different tool. We're not plugging into somebody else's tool. Right? We're doing all of this in one powerful platform. Right? Here we're doing a frame averaging. The average of 10 frames, everything that's in the same place stays. Things that are random are noise, and those go away, and we get the license plate revealed. Very powerful technique. Right? Sometimes motion causes tearing in the image, an old legacy aspect of analog video, and so we could deinterlace and bring that license plate back. Or we can do all of the above. Right? We can stabilize and frame average. Right? We can use these tools in any number of combinations, unlimited amount of combinations to solve problems. Right, sometimes there's a geometric distortion. Oftentimes in body-worn cameras, they all have these wide-angle optics, these fisheye optics, and so we can put that back together. Right? We can restore that problem. We can see around corners. Right? A perspective correction can see around corners. Everything else gets distorted, and I don't really care. I just want the answer to the question: what is the license plate number? And here I have it. Right? I fixed the angle. Right, so the workflow helps establish how we're going to do this. Right, the success of what we're doing depends on the resolution. How many pixels do I have to work with? right? How compressed is the image or the video? What type of blur and focus problems are there? How many frames do I have to work with? How much original data do I have to work with? And then any noise and brightness and contrast issues. So important to understand the defects that are present, right? You have to understand what's wrong with it in order to understand how to fix it. And that's the value of training. We really drill the workflow in terms of building that muscle memory, right? But even again, if we're not able to get the license plate, we might get a make and model, right? And that might be helpful for the investigators. But to wrap up, this is the workflow that we teach in our training sessions, right? We do a case management, a little bit of file triage. Can I actually view the file? If I can't, we can carve out the data stream, bring it into 5, and then what we've been talking about here, content triage. Do I think I can answer the question with this file? If I think I can, I'll work the workflow. If you have any questions, feel free to reach out to us. We can be found online or on the phone. Find us at ampitsoftware.com. You'll find all of our contact information there. Again, my name is Jim Horrocks. It's been my pleasure to host this for you. Have a great day.